Good day. My name is Randy Armstrong. I'm the Chief Architect from Sparhawk Software, and I would like to give you a demonstration today of the Global Discovery Server, which is a important new component from the Unified Architecture specification. I will be doing this demo in three parts in three separate videos. This part one is going to be dealing primarily with application registration and server discovery. Now, before I get into the details of the demo, I wanted to give you a little bit of an overview of the context that we're dealing with. A GDS is a database of OPC UA applications. And in many systems where you're deploying a lot of OPC UA applications, there's a need to manage these applications in a centralized way to reduce the administrative burden, the configuration costs of maintaining the system. And now, once you have this database, there's a number of things you can do with it. One of the things I'll be demonstrating in this video is discovery. It means that you can go in and use a client, and you can search the database for different servers. And this can be very useful if you've got a system where you have multiple locations distributed around the world with OPC UA servers, and you want to be able to go in and go to GDS sitting in the cloud and find the servers that are out there that you can talk to. The other key feature of the GDS comes from security. OPC UA security is all based on PKI, public key encryption, and this requires that certificates be distributed to every application. And along with the certificates, there has to be trust lists as well as revocation lists have to be distributed as well. And there's a need to manage those. And this can be done. Once you've got this database of applications, you can then extend this database to provide these kinds of administrative capabilities. And the last thing is a feature which is necessary to make the GDS sort of a complete solution. And it has to do with auto configuration, meaning it's one thing to have a database of applications, but if this database gets out of date because there's no ability for it to adapt to a changing system, then it's going to be of limited use. So as part of the specification, the OPC Foundation has defined a number of use cases that allow the GDS to auto configure itself to go out and detect the nature of the system that it's connected to and detect changes in that system. So the key, if you're listening to me describe the features of the GDS, you may be thinking that there's lots of other stuff out there that does similar things. And the key advantage of the GDS is it is a UA interface. And what this means is that if you're already building OPC UA applications and deploying them, it's a relatively trivial task to take these applications and extend them to use the information model, which is defined in Part 12 for GDS, and take advantage of these features. If you were to use some other products out there, you would have to incorporate a whole new protocol into your application, which is an additional cost, and plus you have variations from customer to customer. They may not necessarily, or environment to environment, they may not necessarily want to use the same technology to solve these problems. Whereas the GDS is an interface to a solution. So you could have different vendors could come along and create different GDSs that use different underlying technology. For example, Active Directory is a very popular solution that solves a number of the same problems in terms of system management, and it would be easy for a vendor to come along and create a GDS, which is simply a front end to an Active Directory solution. And all of the UA applications themselves would be able to access the Active Directory via the GDS interface without actually having to have any knowledge of Active Directory itself, which will make it a lot easier to integrate in nodes that aren't running Windows in that case. But there's numerous other use cases where having this standard UA interface is makes the GDS much more useful. Now, one of the consequences of the OPC UA interface is you need a client, an OPC UA client, and this client is used to access these services, and there's a couple ways you can do this client. This client can be integrated into your application. And so this is the best solution in the long term, is that you simply extend your existing applications, you add this little bit in there that does the GDS interface, and you give your end users a seamless experience. However, it takes time for that to happen. So in the short term, you're going to have a need for standalone applications which are capable of managing applications which have no knowledge of the GDS, or simply applications that interact on with the GDS on behalf of them. And that is what I'll be showing you today. I'm going to be showing you a client application which is developed by the OPC Foundation, and it's available as sample code to OPC Foundation members. Now, this GDS agent has two modes, management modes. It depends on the kind of application it's dealing with. If it's dealing with a client or a server that has no knowledge of the GDS, then the agent will attempt to update the applications by writing directly to the configuration store, which roughly translated is basically there's files on disk that have to be modified. And this means the GDS agent has to have some knowledge of the configuration of each application. And it also implies that the GDS agent is going to have to be running on the same machine as these applications. But once you've set all of that up, it's relatively quick to, as you will see in the demo, it's very easy to sort of start up, use the agent, go back and interact with the GDS and update these files, and do that over and over again. Now, Part 12 also defines an entire interface that servers can support that allows the remote management of security aspects. So it allows you to update certificates and trust lists and upload CRLs, certificate revocation lists. In this case, the GDS agent will interact with the GDS to sort of do some basic bootstrapping, but once the GDS knows about the server, it can now go back to the server and push out updates to trust lists as circumstances change over time. During the initial configuration, usually you'll have a technician sitting there at a laptop or a tablet computer that will interact directly with the UA server and will be kind of a go-between between the UA server and the GDS, this process will be used for initial provisioning typically. Now, this entire scenario we refer to as push management. Now, last thing I just wanted to show you is the demo that I'm going to the system that I'm going to be showing you here. I have two machines set up here. One's called Bronze, one's called Cobalt. The Bronze machine's got the GDS running on it, a push server, a server that supports the remote management functions, a number of demo servers. Cobalt has a client running there, UA client, as well as a GDS agent. So the first thing I'm doing is I'm starting up the GDS agent, and I'm connecting to the GDS that's running on Bronze. And I'm using a secure connection there, but because I hadn't connected before, I had to I had to trust the certificate, or at least tell the agent to trust the certificate. So you've got a encrypted channel going on here. Now, this panel you see here with all these fields is where some administrator has to provide the agent with all the information about the configuration of the applications that it's managing. And this process has to be done once per application if you haven't integrated the GDS function into the application, into the application. If you integrate this capability into the application, then all of this entire dialog goes away, because the application could fill this stuff in automatically, because it knows its own configuration information. Now, what I'm going to do is simply load the configurations that I have previously prepared and save them on disk. Oh, sorry. And so in this one here, I've loaded the configuration for a UA client, and now I'm going to register it with the GDS. And once I register with the GDS, I get back a unique application identifier that is used for all the other commands that all the other administrative tasks that the GDS supports. The application URI is a unique identifier which allows you to distinguish between different applications. However, you can end up with multiple. You can put multiple applications with the same URI into the database, because this particular identifier is used to distinguish between the different ones. It's not recommended, but that can happen. Now, so this is what I did to manage a client. Now I'm going to do the same with a server. And so this is the pre-can configuration for the server. I'll register it with the GDS. Now, the fields that I filled in here, here's the endpoint URL. Now, this field here is interesting. It only applies to servers. Every server can have a list of server capabilities, which indicate high-level features that the server supports. And this list is it's a finite list. It's defined as part of the OPC UA specification, and the expectation is this list will expand over time as the OPC Foundation identifies different information models which are going to be of interest to clients that are searching for servers. We wanted to keep this list small and using short identifiers in order to optimize the discovery protocol, which I'll be discovering, the multicast discovery protocol, which I'll be discussing in more detail in the next presentation. Now, the last management mode uses the remote management features, which are part of Part 12. So I'm just going to go out on my network, and I'm going to find a server which I know supports remote management, and I'm going to get the information from the server. So in this case, the server's already registered with the GDS, but I'm going to change the server capabilities, and I'm going to update those capabilities in the GDS database. So to recap, what I've done is I've gone through and I've used some pre-can configurations to register a client, register a server that has no knowledge of the GDS, and I've connected to a existing server that supports the remote management capabilities, and I've modified the server capabilities that this particular server is known to support. Well, once we have all this information, we'd like to be able to make use of it, and that's where the discovery dialog comes in place here. And if you're developing any sort of client application, what you're going to want to look at is developing a much more fully featured discovery dialog that allows your users to find machines using a variety of mechanisms. The local machine is basically going to go to the local discovery server that's running on the machine and tell you what's running on this particular machine. You have the local network, which is going to be using multicast to find other servers on the current LAN. I'll be talking about that in the second video. But what I want to show you today is the connection to the global discovery server. In this example, we're assuming there's only one global discovery server, but that's not an assumption that you would want to make in a generic client application because you would want to allow the user to switch between different discovery servers depending on what they're interested in. So I'm just going to search, and it's going to send me back all the servers that are currently known to this particular GDS, and it gives me everything. It's a short list because this is a demo system. But in a real system, you're going to want to put in some search criteria. So the percent signs are wildcards defined by the specification. And now we get back the two demo servers that are running on both machines. And you can see that they've got different capabilities depending on whether the database record was updated by an administrator. So I can also search by specifying that I only want servers that support alarms and conditions, and search, and now I get back the single server. That's the only one in my demonstration that supports that. So as you can see, the number of search terms is fairly limited, but they're actually fairly powerful. So the application URI uniquely identifies a particular application on a particular machine. So if you happen to know what and if you don't know where a machine is, but you've got this unique identifier for it, you can go to the GDS and provide the application URI, and you'll get back that server. And this could even be used to implement a certain amount of location independence if this particular application moves around at different times. The application name is a human readable text that you're searching against. The product URI can be used to identify particular vendors who manufacture something. So let's say you want to find all the servers written by your favorite vendor that are on the network. You simply type in the product URI for those servers, and you would get back the list. And the server capabilities I just demonstrated. So that sort of concludes my demonstration of the process of registering applications with the GDS and then using the client capabilities, the query server capabilities to see what's in the GDS and select the servers that you might be interested in.